Hello, my name is Mr. Chunya. Welcome to my study room. Today I'm solving objective questions 24, 25, 35, and 39 of the 2023 WASSCE Elective or Further Mathematics paper written by Ghana. I choose to put these questions together because they seem to be related. But for the first two, which are 24 and 25, they are actually calculus, which I should have solved when I was solving the questions under calculus, but I think I missed them. So I'll be solving them first before I solve questions 35 and 39, which are mechanic questions. Let's go straight to questions 24 and 25, and it has the problem or preamble stated that the distance s meters covered by a body thrown vertically upwards at any time t seconds is given by s equals 32t minus 4t squared. Use this information to answer questions 24 and 25. And the question 24 says that find the greatest height reached by the body. I stated earlier that this question is an application of calculus. So let me first rewrite the equation, and we have to find the greatest height reached by the body. The first thing I would like us to know is that at the greatest height, the first derivative of this equation will be 0. So let me write that. So at the greatest height, ds dt means that the first derivative of s with respect to t will be equal to 0. So let me go straight ahead to find the first derivative of this equation. So ds dt will be equal to, when you differentiate 32t, you will get 32 minus, when you differentiate 4t squared, the 2 will come and multiply the 4, which will give us 8. And then 2 minus 1 is 1, so that will give us t. And I already said that ds dt is equal to 0 at the greatest height. So I'm going to equate this to 0 and then solve for t. And that means that 32 minus 8t equal to 0. And when we move 8t to the right side, we will get 32 being equal to 8t. Dividing both sides by 8, t will be equal to 4. And this means that at the greatest height, the time equals 4 seconds, or the time equals 4 seconds at the greatest height. So now what we are going to do is that we are going to substitute that into the original equation, which is s equal to 32t minus 4t squared, so that we will see the height, which is the distance upward covered when the time equal to 4 seconds. So that's what we are going to do now. We'll rewrite the equation as s equals 32, wherever we see t, we put 4 there, minus 4 squared. And that will give us, let's use our calculator, 32 multiplying 4 minus 4 multiplying 4 squared, and that has given us 64. So that means that the greatest height reached by the body is 64 meters. And looking through, that is option C. Then we move to 25. 25 says that calculate the time taken to reach the greatest height. And we've already calculated that. I said earlier that it means that the time at the greatest height is 4 seconds. So that is option C. Let's now move to question 35. Question 35 says that a force of 24 Newton acts on a body of mass 3 kg, which is at rest. How far will the body move in 4 seconds? The key facts from this problem are that the force is 24 Newton and the mass of the body is 3 kg. Also, the body is at rest, meaning that the initial velocity is 0 and the time is 4 seconds. And then what we are solving for is how far will the body move in 4 seconds. Good. This is mechanics, and we will need equations of motion to be able to solve this. And more specifically, we need Newton's second equation of motion, which is S equals ut plus 1/2 at squared, where S is displacement, U is initial velocity, T is time, and A is acceleration. And from this equation, we are solving for displacement, which is the distance traveled in a specific direction. And then we know the U, which is the initial velocity at 0 because the body is at rest. We know the time, which is 4 seconds, but we don't know acceleration. So we need to use the force equation to be able to solve for acceleration. And that is force equals mass times acceleration. So in this case, the force is 24 Newton and mass is 3 kilogram. We don't know acceleration, so we're solving for acceleration. Dividing both sides by 3, acceleration will be equal to 8 meter per second squared. Now we can go back to the equation here now and plug in all these values. So now displacement becomes U is 0, T is 4, plus 1/2, acceleration is 8, times time is 4, so 4 squared. And displacement to be equal to 0 plus 8 divided by 2 is 4. 4 times 16 is 64. So that means the body will move 64 meters in 4 seconds. And looking at the options, that is option D. Let's move to question 39, which is the last for this study. Question 39 reads that 3 forces, 10I plus 5J Newton, 2I minus J Newton, and then negative 8I minus 7J Newton act on a body. Find a single force, F, that will keep the body in equilibrium. We'll first start by letting the 3 forces be F1, F2, and F3 respectively. And also the question says we should find the single force that will keep the body in equilibrium. And in simply put, the body will be in equilibrium if the sum of all 4 forces equal to 0. Let me write that too. Now that we know this, we are just going to write these forces in the column form and then solve for F. That's just what we're going to do. So this one becomes 10, 5 plus F2 be 2 negative 1 because the coefficient of the J will be negative 1. F3 will be negative 8, negative 7. And then we don't know that of F equals 0. First of all, 10 plus 2 is 12, minus 8 is 4. And then 5 minus 1 is 4. Minus 7 is negative 3 plus F equals 0. When we move this to the right side, F now becomes negative 4, negative 3, which when we expand, negative 1 times 4 will be negative 4, negative 1 times negative 3 will be positive 3. So it means that the entries for F will be negative 4I plus 3J Newton. And when we look through the options, that is option C. And this is where we end our studies for today. I hope this has been of help to you. If yes, then kindly consider subscribing to this channel for more videos like this. Till we meet again in my study room. Bye bye.